Hi everyone, welcome to the chapter on kinematics. Let me first talk about the displacement time graph. Over here on the left, you see a graph of displacements against time. So on the displacement time graph, what's the significance of the gradient? The gradient is the change in displacement divided by the change in time, delta s over delta t here. So you can see that the unit is actually meter divided by second. And that is exactly the unit for velocity. So the gradient on the displacement time graph represents velocity. Now with this understanding that the gradient on the displacement time graph represents velocity, you can see that when time is between 0 and t1, velocity v1 equals to gradient m1 equals to s1 divided by t1. So if you are given a displacement time graph like this, you can calculate the gradient using S1 divided by T1. And for time between T1 and T2, you realize that the velocity is 0 because the gradient M2 is 0. And when T is greater than T2, the object is again moving because you can see that the gradient is non-zero. And the velocity v3 is given by the gradient m3. Now let's move on to velocity time graph. So on the left, you have a velocity time graph. So what's the significance of the area under the curve and the gradient? So first, area under the curve. So what does the area under the curve represent? So to answer this, we look at the unit of the area. The unit for this area is actually meter per second, the vertical axis, multiplied by seconds, the horizontal axis. And this gives meters, which is the unit for displacement. So the area under the curve represents displacement. Now let's move on to gradient. Gradient, for example m1, as you can see on the graph. What is the unit of the gradient? The unit is meter per second divided by second, which gives you meter per second square. And that is exactly the unit for acceleration. In other words, the gradient on the velocity time graph represents acceleration. Now let us look at an example. In this example, a bullet penetrated a block with an initial velocity of 100 meters per second. It comes to a complete stop after traveling 0.1 meter into the block. So given this information, you can actually plot out a velocity time graph here on the left. When time t equals to 0, the velocity is 100 meters per second. After time t0, which is an unknown, the bullet comes to a stop. In other words, v equals to 0. So now, in this example, we want to find t0 as well as the acceleration a. Now let's find t0 first. We have learned that in a velocity time graph, the area under the graph represents the displacement. So we can write down this equation here. Half times t0 times 100, which is the area of a triangle, is equals to 0.1 meter, which is the displacement. So from here, we can arrive at t0 equals to 0.002 seconds. Now with t0, we can easily find a, acceleration. Acceleration is equals to the gradient of the straight line you see on the left. And the gradient is given by 0 minus 100 divided by t0, which is 0.002. And this gives us the answer, negative 50,000 meters per second square. Okay, we have come to the end of the lesson. I hope you have found the lesson interesting and useful. And if you need to contact me, you can find my email address on the top right hand corner. Thank you.